Our story begins in the dusty plains of Mesopotamia. Imagine the Babylonians, more than 4,000 years ago. They were great builders and astronomers. They needed to measure their fields and chart the stars. To do this, they needed to understand circles. They noticed a relationship, a secret code, hidden in every circle. They saw that the distance around a circle, its circumference, was always about 3 times bigger than the distance across it, its diameter. This was a huge discovery. They didn't call it pi, but they knew this special number existed. They used a simple fraction, 3 1/8, or 3.125, as their value. It was a good start, a first guess at a number that would fascinate humanity for millennia. A little to the west, along the fertile banks of the Nile, the ancient Egyptians were also building wonders. They constructed enormous pyramids and temples. Their mathematics was very practical, born from the need to build, to measure land after the annual floods, and to create a working society. In a famous document called the Rind Papyrus, we find their attempt to solve the circle's puzzle. The scribe, Ahmes, wrote down a method for finding the area of a circle. From his calculations, we can see they used a value of about 3.1605 for pi. This was a different number from the Babylonians, but it was also very close. These early civilizations were like explorers on the edge of a vast unknown ocean, getting their first glimpses of a hidden continent of mathematics. The search for this mysterious number even appears in ancient religious texts. In the Hebrew Bible, in the first book of Kings, there is a description of a large circular basin in King Solomon's temple. The text says it was 10 cubits from one brim to the other, and a line of 30 cubits did compass it round about. If you divide the circumference, 30, by the diameter, 10, you get exactly 3. This is a very simple approximation. It might not have been a precise mathematical statement, perhaps it was just a general description, but it shows that the idea of this special ratio, this constant relationship in all circles, was part of the common knowledge of the ancient world. They all knew the secret was there. These first attempts were not perfect, but they were brilliant for their time. They were made without modern tools, without calculators, without even the number 0 as we know it. These ancient thinkers used what they had: ropes, sticks, and their own clever minds. They were driven by practical needs, building, farming, measuring, but they were also driven by something more powerful: curiosity. They saw a pattern in the world around them, a rule that governed every circle, from the sun in the sky to the wheels on their carts. They had started a journey, a great mathematical adventure. They had asked a question that would echo through the ages: what is the true value of this circle number? The story of pi now travels to ancient Greece. The Greeks loved logic, geometry, and proof. They were not satisfied with just good approximations. They wanted to understand things with perfect certainty. This is where a brilliant mind named Archimedes of Syracuse enters our story. He lived more than 2,200 years ago. Archimedes was a true genius, an inventor, a physicist, and a mathematician. He decided to tackle the problem of pi in a completely new and clever way. He did not want to just measure circles with ropes. He wanted to trap the true value of pi between two other numbers, getting closer and closer to it. Archimedes had a beautiful idea. He knew he could not measure the curved line of a circle perfectly, but he could measure straight lines. So, he drew a polygon, a shape with straight sides, inside a circle. He started with a simple hexagon, a shape with 6 sides. He calculated its perimeter. He knew this perimeter had to be slightly smaller than the circle's circumference. Then, he drew another hexagon outside the circle. He calculated its perimeter. He knew this had to be slightly larger than the circumference. The true value of the circle's circumference, and therefore pi, was trapped between these two values. But Archimedes did not stop there. A hexagon was just the beginning. He realized he could get a much better estimate if he used polygons with more sides. More sides meant the polygon would fit the curve of the circle more closely, so he doubled the number of sides. From a hexagon, he went to a 12-sided polygon, then a 24-sided one, then a 48-sided one, and finally, a 96-sided polygon. The calculations became incredibly difficult. He was working without decimal points or modern algebraic notation, yet he patiently worked through every step. His mind was his only computer. After all this hard work, Archimedes found his answer. He proved that the value of pi was less than 3 1/7 but greater than 3 10/71. In modern numbers, this means pi is somewhere between 3.1408 and 3.1428. This was the most accurate calculation of pi the world had ever seen. The fraction 22/7, which equals about 3.1428, became the standard approximation for pi for centuries. Archimedes' method was a monumental achievement. He had shown that you could use pure logic and geometry to uncover the secrets of a number that seemed beyond reach. He had set a new standard for mathematical rigor and inspired generations of mathematicians to continue the chase. For many centuries, Archimedes' record stood unchallenged in the Western world, but the quest for pi was a global story. Far away in China, mathematicians were also captivated by the circle's secret. They were developing their own sophisticated mathematical traditions. Around the year 500, a brilliant Chinese mathematician and astronomer named Zhu Chongzhi made a spectacular leap forward. He was not content with the old approximations. He wanted to find a value for pi that was more accurate than ever before. He started with Archimedes' polygon method, but he took it to an astonishing new level of complexity. Zhu Chongzhi was incredibly patient and determined. We believe he used a polygon with an incredible 24,576 sides. Imagine the calculations this would require. He had to work with very long numbers, all by hand, using counting rods on a special board. His dedication was extraordinary. After years of painstaking work, he arrived at two new results. He gave a simple fraction for everyday use: 355/113. This fraction is amazingly accurate. It is correct to 6 decimal places: 3.14159. It is so good that it remained the most accurate fraction for pi for nearly 1,000 years. It is a masterpiece of calculation. But Zhu Chongzhi didn't stop with the fraction. He also calculated a range for pi, just like Archimedes had done. But his range was much, much tighter. He stated that pi was between 3.1415926 and 3.1415927. This was an unprecedented level of accuracy. He had found pi correct to 7 decimal places. This record would not be broken anywhere in the world for almost 900 years. It was a golden age for Chinese mathematics, and Zhu Chongzhi's work was its crowning achievement. His discovery was a testament to the power of pure dedication and intellectual stamina in the search for mathematical truth. Meanwhile, in India, another great mathematical culture was flourishing. Indian mathematicians made huge contributions, including the development of our modern number system with the concept of zero. Around the 14th century, a remarkable mathematician named Madhava of Sangama Grama found a completely new way to think about pi. He did not use polygons. Instead, he used an infinite series. This was a revolutionary idea. An infinite series is like a recipe, with an endless list of ingredients that you keep adding. Madhava found a series of fractions that, when added and subtracted in a special pattern, would get closer and closer to the true value of pi. This was the beginning of calculus, centuries before it was formally developed in Europe. Madhava used his series to calculate pi to 11 decimal places, breaking Zhu Chongzhi's long-standing record. The long and difficult search for pi was not just about practical things like building wheels or measuring land. For many ancient cultures, this special number held a deeper meaning. It was seen as a key to understanding the universe itself. The circle was a powerful symbol. It represented eternity, with no beginning and no end. It represented perfection, harmony, and divinity. The sun and the moon, which governed life on Earth, were circles in the sky. So, the number that unlocked the secrets of the circle, pi, was naturally seen as something special, almost magical. It was a bridge between the physical world we can measure and a perfect ideal world of shapes and ideas. In the philosophy of the ancient Greeks, especially Plato, geometry was a path to enlightenment. Shapes like the circle were considered perfect forms, existing in a higher realm of ideas. The circles we draw in the sand are just imperfect copies of this true, ideal circle. Pi, as the fundamental constant of all circles, was part of this perfect world. To study pi was to get a glimpse of this divine reality. It was a philosophical pursuit, an exercise for the soul as much as for the mind. Understanding pi was part of understanding the fundamental structure of the cosmos. It was more than a number, it was a cosmic principle. This sense of wonder was not limited to the Greeks. In many cultures, the universe was pictured as a series of concentric circles or spheres. Think of mandalas in Buddhist and Hindu traditions. These are complex circular designs used for meditation. They represent the universe and the path to enlightenment. The geometry of the circle is central to their spiritual meaning. The constant that governs this sacred geometry, pi, would have been seen as part of this spiritual fabric. It was a number that embodied balance, unity, and the cyclical nature of life and the cosmos. It was a secret code written into the very design of existence. So, when people like Archimedes or Zhu Chongji spent years calculating pi, they were doing more than just math. They were on a kind of spiritual quest. They were trying to get closer to a fundamental truth. The fact that pi's digits seemed to go on forever without a pattern only added to its mystery. It was a number that you could get closer and closer to, but never fully grasp. This made it a powerful symbol for the infinite and the unknowable. Pi was a humble number, born from a simple circle, but it touched upon the biggest questions of existence, perfection, infinity, and the hidden order of the universe. For thousands of years, the main tool for calculating pi was the polygon method. It was clever, but honestly, it was also incredibly slow and difficult. Each new decimal place required a massive increase in effort, but in the 17th century, everything changed. A new kind of mathematics was born in Europe, calculus. Developed by Isaac Newton and Gottfried Wilhelm Leibniz, calculus was the mathematics of change and motion. It provided a powerful new language for describing the world, and it gave mathematicians a whole new set of tools for hunting pi. The age of polygons was coming to an end. Calculus allowed mathematicians to use the infinite series that Madhava had discovered in India centuries earlier. But now, they had a stronger, theoretical foundation to understand and create new, even more powerful series. Imagine a recipe where each new ingredient you add gets you to your goal much, much faster. That is what these new series were like. In 1671, the Scottish mathematician James Gregory discovered a series for arctangent, which could be used to calculate pi. A few years later, Leibniz independently found a famous, beautifully simple series for pi, 4 minus 4/3 plus 4/5 minus 4/7 plus 4/9, and so on forever. While Leibniz's series was beautiful, it was not very fast. You had to add a huge number of terms to get just a few decimal places. But other mathematicians soon found much better formulas. In 1706, John Machine developed a clever new formula that was much more efficient. Using his formula, he was able to calculate pi to an amazing 100 decimal places. This shattered all previous records. He did it all by hand, of course. For the next 250 years, Machine's formula, and others like it, became the main weapon in the hunt for the digits of pi. The race was on. This new era also saw the official naming of our number. Although people had been studying it for millennia, it didn't have a standard symbol. In 1706, a Welsh mathematician named William Jones was the first to use the Greek letter pi to represent the famous ratio. He chose it because it is the first letter of the Greek words for periphery and perimeter. The symbol was later popularized by the great Swiss mathematician Leonhard Euler in the 1730s. Thanks to Euler's widespread influence, pi became the universal symbol for this fundamental constant. The ancient mystery now had a modern name. The stage was set for even more incredible discoveries. As mathematicians calculated more and more digits of pi, they began to wonder about its true nature. They had hundreds of digits, but they saw no repeating pattern. Was pi like the fraction 1/7, which becomes a repeating decimal, 0.142857, 142,857, and so on? A number that can be written as a simple fraction is called a rational number. For a long time, no one knew if pi was rational or not. If it was, it meant that eventually, its decimal digits would have to fall into a repeating loop. But the digits they had calculated just seemed random and chaotic. The mystery deepened. The answer finally came in 1761. A Swiss-German mathematician named Johann Heinrich Lambert proved that pi is an irrational number. This was a huge breakthrough. It meant that pi cannot be written as a fraction of two whole numbers. No matter how clever you are, you will never find a fraction, like 22/7 or 355/113, that is exactly equal to pi. They are only approximations. Lambert's proof confirmed what mathematicians had long suspected. The digits of pi go on forever without ever repeating in a pattern. It has an infinitely long, non-repeating tail. This discovery changed how people thought about pi. It was not just a difficult number to calculate, it was fundamentally different from the simple numbers of everyday arithmetic. The story of pi's nature has another chapter. Over a century after Lambert's discovery, in 1882, another German mathematician, Ferdinand von Lindemann, proved something even more profound. He proved that pi is a transcendental number. This is a very special and rare type of irrational number. Being transcendental means that pi is not the solution to any polynomial equation with rational coefficients. This might sound very technical, but it has a very important consequence. It finally solved an ancient problem that had puzzled Greek mathematicians for over 2,000 years, the problem of squaring the circle. The ancient challenge was to construct a square with the exact same area as a given circle, using only a compass and a straight edge. For centuries, amateur and professional mathematicians had tried and failed. Lindemann's proof showed that it was not just difficult, it was logically impossible. Because pi is transcendental, you simply cannot construct a length equal to the square root of pi using only a compass and straight edge. The quest was over. Pi was not just irrational, it was a member of an exclusive club of numbers that exist beyond the realm of simple algebra and geometry. Its mystery was not one of calculation, but of its fundamental essence. For centuries, calculating pi was a human endurance test. Mathematicians would spend years of their lives hunched over paper, slowly and carefully working out each new digit. The record for manual calculation was set in 1946 by D.F. Ferguson, who reached 620 digits. But, just as this record was set, a new tool was about to change the game forever: the electronic computer. The arrival of computers in the mid-20th century launched the hunt for pi into a completely new dimension. What once took years could now be done in hours, and then minutes. The first computer calculation of pi happened in 1949. Using the ENIAC, one of the earliest electronic computers, John von Neumann and his team calculated 2,037 digits of pi. It took the machine 70 hours. This was more than 3 times the previous record, and it was just the beginning. As computers became faster and more powerful, the pi calculation records began to fall like dominoes. By 1961, they had reached 100,000 digits. By 1973, it was 1 million digits. The numbers became astronomical, far beyond anything a human could ever hope to calculate by hand. The quest for pi became a benchmark for testing new computers. Calculating billions of digits of pi is like a stress test for a computer's processor and memory. It pushes the hardware to its absolute limit. If a computer can successfully complete a massive pi calculation, it proves that its systems are stable and reliable. Furthermore, the algorithms, or mathematical recipes, used to calculate pi also became more sophisticated. In the 1980s, new algorithms were discovered that were much faster than the old machine-like formulas. These modern methods allowed the number of known digits to explode. Today, in 2026, the record for calculating pi stands in the trillions of digits. We have now computed over 100 trillion digits of pi. This number is so vast that if you were to print it out in a normal font, the line of digits would stretch around the Earth thousands of times. We have so many digits that we will never be able to look at them all. This incredible feat is a tribute to human ingenuity, the power of mathematics, and the phenomenal speed of modern technology. The ancient quest that began with ropes and sticks has led us to the era of supercomputers, all in pursuit of this single mysterious number. With trillions of digits of pi stored on hard drives, you might ask, why do we need them? For most practical purposes, you only need a few decimal places. To calculate the circumference of the entire observable universe to the accuracy of a single atom, you would only need about 40 digits of pi. So, the search for more digits is a purely mathematical pursuit, a challenge like climbing Mount Everest. But the pi we already know is incredibly important. It is not just a curiosity, it is woven into the fabric of our modern world. You cannot escape pi, it is hidden in the technology we use every day. Think about science and engineering. If you want to build anything that is circular or spherical, you need pi. Engineers use pi to design engines, pipes, and wheels. Architects use it to design buildings with domes or curved walls. Pi is essential in physics. It appears in the equations that describe waves, from the ripples in a pond, to the sound waves that travel to your ear, to the light waves that allow you to see. It even shows up in Einstein's theory of relativity, which describes the structure of the universe. Pi is also fundamental to electrical engineering, signal processing, and telecommunications. The smartphone in your pocket relies on formulas involving pi to work. Pi's reach extends into the world of technology and data. Your GPS system uses pi to calculate positions on our spherical planet. When you listen to music or watch a video, the data is often processed using a mathematical technique called the Fourier transform. Pi is a central part of this formula. It helps to break down complex signals into simple waves. Without pi, we could not have digital audio, image compression like JPEGs, or many of the other technologies that power our digital lives. It is a silent partner in much of the information we consume. Even nature itself seems to know about pi. Pi appears in the double helix of our DNA. It describes the beautiful curves of rivers and the shape of a pupil in an eye. It helps us understand probability and statistics. For example, in the famous normal distribution or bell curve that describes so many natural phenomena, from the smallest particles to the largest galaxies, pi is there. It is a universal constant that links the abstract world of mathematics to the real physical world we inhabit. It is a reminder that our universe has an underlying mathematical structure, and pi is one of its most important letters. The journey of pi is more than a history of a number. It is the story of human curiosity. It is a story that connects the ancient Babylonians measuring fields with ropes to the modern scientists programming supercomputers. For over 4,000 years, this single number has captivated the minds of the greatest thinkers. It has been a constant companion on our journey of discovery. The quest for pi shows us a beautiful thread running through human history. The shared desire to understand the world, to find patterns, and to solve puzzles just for the joy of solving them. It is a story that belongs to all of us. The character of pi itself seems to mirror our quest. Its digits go on forever, with no discernible pattern. In the same way, our search for knowledge is endless. Every time we answer one question, we uncover new ones. The trillions of digits of pi we have found represent the vast amount of knowledge we have accumulated. But the infinite digits we have not yet found represent the infinite mystery that still lies ahead. Pi is both a symbol of what we have achieved and a humble reminder of how much more there is to learn. It teaches us that the pursuit of knowledge is a journey, not a destination. From a practical tool for ancient builders to a mystical symbol for philosophers, from a test for modern computers to a key ingredient in today's technology, pi has played many roles. It is a testament to the power of mathematics to be both incredibly useful and profoundly beautiful. It shows us that a simple observation about a circle can lead to a deep understanding of the universe. The story of pi is a perfect example of how pure, curiosity-driven research can eventually lead to incredible practical applications that change the world in ways the original thinkers could never have imagined. So the next time you see a circle, whether it is the moon in the sky, a pizza on your table, or an icon on your screen, take a moment to think of pi. Think of the thousands of years of human effort, the brilliant minds from different cultures, and the incredible journey from a simple guess of 3 to trillions of digits. The story of pi is our story. It is a story of our relentless drive to explore, to calculate, and to understand. And because pi is infinite, it is a story that will never truly have an end. The quest continues.